Hey, welcome to Unit 1, Lesson 3. This is kind of that second part of our sequences. So in Lesson 2, we talked about arithmetic sequences. So now here we're doing geometric. Now remember, geometric sequences, we are multiplying each time. Okay, and we'll kind of see how that works. So kind of that big hint here, how are the bunnies changing? Well, look here, you can see these red ones, and there's 6 to start. Okay. Now, hint, hint, geometric, it's probably multiplying. You can kind of see how, like, holy cow, down here there's a ton of bunnies. So we can see it's multiplying, but multiplying by what? Okay. So I know there's 6 here in the first one. Here there's 6 here, another 6, another 6, another 6, another 6. Okay, well, how many groups of 6 are there? There's 5. 5 times 6 is 30. Okay, so there's 30 bunnies in that second picture. Okay. So I'm kind of seeing here, this is like, how would I get from 6 to 30 when we multiplied by 5? Okay, let's double check that would be the same. If I did, let's see if we multiply it by 5. So here's 1, here's the original, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so those are 20 right here. 20 groups of 6, I should say, right? So that's 120 plus these 30 that we started with. This would be 150. It'd be 150 bunnies there, which means 30 to get to 150, we multiply by 5. Okay, so how are the bunnies changing? They're multiplying by 5. You could just do that. You could write that, multiplying by 5. And you can see that they're just like getting bigger and bigger and bigger. Now remember, if you're like unsure about how to find out how to get from 6 to 30, you can always go back and do 30 divided by 6. And that'll get you the 5 that you're multiplying by. Okay? To figure out the 6th figure, that 6th picture, you could keep multiplying. So and I like to do the table, right? And I talk about using your fingers too. So in the first picture, there are 6. In the second picture, there are 30. In the third, there are 150. We're going to go all the way to the 6th picture, okay? So I know that we're multiplying by 5, so I'm going to take out my handy-dandy calculator, and this, I'm just going to multiply by 5. 150 times 5. 750. And then just kind of continue that, times that by 5. I get 3,750 in the 5th picture. So in the 6th picture, holy smokes, there's 18,750 bunnies. Okay, so for these geometric sequences, we're just going to keep on multiplying over and over and over again to figure out what we got. Okay, let's get into some more of the kind of the graphing in the picture. So here it's kind of starting out similar to what we did with arithmetic sequences. We're going to graph it, make a table, all that stuff. So first it says describe how the numbers are changing. Well, let's take a look here. That would be like multiplying by 2. From 2 to 4 is like multiplying by 2. 4 times 2 is 8. 8 times 2 is 16. So I can see that multiplication by 2. So describe how the numbers are changing. You can just write times 2. That's how they're changing. Okay. Let's say we thought that it was adding. Okay, so this would be adding 1 to 2. 2 to 4 would be adding 2. Oh, okay, so like it has to be the same, right? For it to be arithmetic, it had to be the same. So right away, you can kind of tell that that's not the case. Let's fill in the table. So the first is 1, second is 2, third is 4, the fourth number is 8, the fifth number is 16, and if we multiply by 2, that would be 32. Okay. Let's graph it first, and then we'll kind of move on to that next question. So the first one is 1. That'd be like 1 comma 1. The second one is 2. Okay, you can see how this looks kind of like a straight line. The third one is 4. The fourth one, 1, 2, 3, 4, 5, 6, 7, 8. The fourth one is 8. Okay, so this is not a straight line. You know, we can't connect these using a straight line anyway. This actually is kind of a curved line. It's going to keep on going way up and up and up. Okay, it's called exponential, and we'll kind of get into that later on this year. But just know that it's not linear, or it's not a line. Okay, so this equation we used for arithmetic does not work for geometric. We have to come up with something else, okay? And this hopefully will kind of help us figure that out. It says, what is the number that comes before the first term? Well, if right here we're multiplying by 2 from one to the next, multiplying by 2, what would I be doing going backwards? And I hope you all said dividing by 2. Okay, so the one that comes before, if we divide by 2, what's 1 divided by 2? It would be 0.5, okay? If you did 0.5, that's okay. If you did 1/2, that's also okay. All right, it's kind of like doing 1 divided by 2. That's what the 1/2 is, okay? The 1 divided by 2. So you could write it as a fraction, or you could just do it as decimal. Doesn't matter to me. That would be the, we'll say like the 0 term, or the y-intercept, okay? There's still a y-intercept, even if it's not linear. Now it says write an equation for the sequence. This next part here that I write down, don't write it down. I'm just gonna kind of write it to have you think about it. So do not write this down that I'm writing in black. Okay, it says write an equation for the sequence. So I know that we're multiplying by 2 over and over and over again. Times 2, times 2, times 2, times 2, times 2. And we keep on doing that. So I guess my question would be, is when you multiply over and over and over again, let's see, let's do this. We have 1, 2, 3, 4, 5. We have 6 2's right there. That's the same as doing 2 to the power of 6. Okay, not 2 times 6 is 2 to the power of 6. And that's going to help us write out this equation. Okay, so I'm going to start out with y equals. Now this is what you can write down. Okay, we can start with this 0.5. Okay, so y equals 0.5. And then times, what are we multiplying by each time? 2. So times 2 to the power of x. Okay, because we're multiplying over and over and over again, so that's going to bring that up into the exponent, 2 to the power of x. Okay, that's going to give it this, you can kind of tell it's a curved shape right here on the graph. If we were to kind of expand it out, it might look more like this. There might be others that look more kind of spread out like that, but you can still see that it's not just a straight line, okay? Then it says, what is the 10th term? Again, you could continue using this table, and then know that the 7th would be 64, the 8th is 128, and so on, okay? But I'm just going to go 0.5 times 2 to the power of 10, okay? And just a heads up, you cannot multiply this first. You do not do that. You want to do 2 to the power of 10, okay? Remember PEMDAS? parentheses, and exponents come before multiplication. So 2 to the power of 10 is 1,024. And then you can multiply that by 0.5. It would be 512. Okay, that would be the 10th term is 512. If you typed this in your calculator, just like that, if you have like a graphing calculator, scientific calculator, or Desmos, it would just give you the 512 too. So you could practice that if you want. Just plug it in and see if you get that. Then you don't have to worry about that order of operations, especially if you have Desmos. You can just plug that right in. Okay, so you should get 512 as the 10th term. Just have a few more examples, if you can see at the bottom. We're going to work our way towards actually kind of a new formula. Okay. So here it says find the next two terms. I say the first term is 4. We're going 4 to 8 to 16. So this is, again, multiplying by 2, right? And if you didn't recognize that, that's okay. Just do 8 divided by 4. See what you get. And make sure that it's the same as doing 16 divided by 8. Okay, so you can go backwards and use division to try and figure out what it is. And just make sure that it's consistent. So we're going to keep on going. 32 times 2 is 64. And then 64 times 2 is 128. So how is the sequence changing? It's multiplying by 2. And then the 9th term, well, we could keep going. This is the first term, 2nd, 3rd, 4th, 5th, 6th. If I did 128 times 2, that'd be the 7th term. 8th term is 512, and the 9th term would be 1024. Okay. Now, yes, we could have done this with the formula and gone backwards and figured that out, but I figured 9th term's not too bad. Okay. Okay. Actually, I'll show that with the formula. Okay, so if we went backwards to find that first term, because remember, we're not starting with that 4. We have to go back. You have to do divided by 2 to get that 0 term, that number in front. So 4 divided by 2 is 2. So I do 2 to start. We are multiplying by 2 each time, and then to the power of 9. And if I plug that in all the way, I do get 1024. Okay? So that works. You could do it either way. Like I said, 9th term is not too bad to try and just plug in and keep on going up to. Let's try this next one here. So remember, if you're like, oh man, how do I do that? How do I figure out what it's multiplying by? Let's just do 6 divided by 2. So I'm doing 6 divided by 2. 6 divided by 2 is 3. Okay. 18 divided by 6, that's 3. Perfect. Okay, so that's the same thing. Like, it has to be the same. So I know that it's multiplying by 3. I can say multiplying by 3. 54 times 3 is 162. And then times 3 is 486. So remember, this is the 1st, 2nd, 3rd, 4th, 5th, 6th. So here it's like, okay, the 7th term, all I have to do is multiply that by 3 one more time. 1, 4, 5, 8. Okay. So there's no reason really to do a formula here. You're just multiplying 486 by 3 one more time. If you did go backwards, remember you'd have to divide by 3, and then if you have 2 divided by 3, it's 0.6 repeating, and it's just kind of a funky number to work with. And that's okay, you can do that, but again, 7th term, not a big deal to just go on and do one more. Okay, and we'll actually figure out something with this, because that's might cause some issues later on, so we're going to figure out a new way to write a formula to make it a little bit easier on us. So let's try these ones out. So here from 7 to 35, well, I know that 7 times 5 is 35. 35 times 5 is 175. And we can keep on multiplying that. 875 and then times 5 to get 4, 3, 7, 5. How is the sequence changing? Well, it's multiplying by 5. Okay, now it says write an equation for this sequence. Okay, and we can go back 1. But remember, we have to divide by 5. And then you get 7 divided by 5, which is not bad. Like, it's just 1.4. But I'm going to try something else here. I'm not going to do that, because that's just like an extra step that I don't want to do. So instead, what I can do is I can start with that 7 out front, that first term. We're going to multiply by 5 each time, and then raise it to the power, instead of to the power of x, like we had, which is good. We're going to start with that. We're going to do x minus 1. Okay. That's one other way to write an equation for that sequence. The reason why we do this minus 1 right here up top is because we're starting with a sub 1. We're starting with the first term instead of before we always went back. Well, we're not going back, so we have to have that x minus 1 up top. Okay, so when it says what is the 8th term, we could still do 7 times 5, and then you do 8 minus 1. Okay. If you do right away, do it to the power of 7 because you do 8 minus 1 in your head, that's okay. And then you can just plug that in. I get 546,875. Okay, so let's try it with letter D. It's the last one. Wait a minute though, this one's going down. I'm going from like 6,000 to 2,000 to 700. Well, it's kind of hard for me to figure out what it's going down by, so we can still do 2,187 divided by 6561. So 2187 divided by 6561. I get 0.3 repeating. Okay, which actually is the same as 1/3. Okay. Now I'm going to try and see if it's continuous or whatever, if it's consistent, I should say. So I'm going to do 729 divided by 2187. Plug that in, and you get the same exact thing, 0.3 repeating, or 1/3. Okay, so for how is the sequence changing, I'm going to leave this up to you. I prefer saying multiplying by 1/3. Okay, and the reason why I say 1/3 is because when you type it in your calculator, it's kind of hard to do the repeating 3. So I'm going to say timesing by 1/3. If you said dividing by 3, that's also okay. You're just going to run into some issues here with writing the equation. Okay, but if you recognize that you're dividing by 3, that's fine. So to figure out the next term, you could do, for this one here, 729, and then parentheses 1 divided by 3. Like, close it off like that. That's the same as multiplying by 1/3. And then you'd get 243. And then for this one, you do the same thing, 243, parentheses 1 divided by 3. And then that would be 81. Okay, write an equation for this sequence. So again, I'm going to kind of go back to that previous example. I'm not going to go backwards here. I'm not going to do that. That's just too much work. So I'm going to start with 6561, and then parentheses, we're multiplying by 1/3. And then to the power of x minus 1. Remember that minus 1 on top. Okay. What is the 7th term? I can do 6561 times 1/3, and then to the power of 7 minus 1. Or if I simplified that, 1/3 to the power of 6. So 6, 5, 6, 1, parentheses, 1 divided by 3, close it. So make sure you close this parentheses off. To the power of 6, I get 9. 9 is the 7th term. Okay? Thanks for sticking with me. I know I have some practice on the back for y'all to try out. And then just let me know if you have any questions.